This video is going to cover complex numbers. So we've been learning about imaginary numbers and we know what real numbers are, but what happens if we combine the two? What if we have a real number and an imaginary number in the same expression? And that is where we get complex numbers. So a complex number has both a real part and an imaginary part. And often we write them in kind of a standard form, which we would call A plus BI. Okay, so A represents the real part. A is a real number. It does not have an I, which means it is not imaginary. It's the real number. And then plus BI. BI represents the imaginary piece. B would be a number, and that number would be multiplied by I. So B and I would go together, and that's the imaginary piece. Now, this is also what we consider to be standard form. So when you write an imaginary number, it is proper math notation to always write the imaginary term last. Real first, then imaginary. Some examples of complex numbers are down below. We've got -2 plus 6i. In this example, -2, that's the real, and 6i, that's the imaginary. Now in the next one, notice it's 4 minus I. Well, our standard form has plus, but that could be a plus, it could be a minus. So this is still a complex number. 4 is the real part, minus I is the imaginary. In this case, B would be -1. And then we have one more, which is 100 minus 0.5i. 100 being the real part, and then -0.5i, that's the imaginary piece. So B does not have to be a whole number either. It can be negative, it can be positive, it could be a fraction, a decimal, or a whole number. And the same can go for A. Now, where do complex numbers fit into the number family tree? Complex numbers is the top of the family tree. So all numbers can be considered a complex number. But when a complex number is missing a part of the full standard form, that's when it breaks down into the more specific categories. So a complex number, A plus BI. Well, if an A plus BI, A is 0, if A is 0, then that would make it an imaginary number because you'd be left with just BI. So anytime you don't have a real part, that would become an imaginary number. But for real numbers, that would be if B was equal to 0. So that's when we don't have the imaginary part, but we have the real. And then with real numbers, we've learned that there are some more types within that category. So we have rational numbers, which would be whole numbers, fractions. We have integers, which is just -4, 0, 1. That's also whole numbers. We've got natural numbers. But on the flip side of rationals, we have those irrational numbers. So that's like pi, the square root of -2. We've also learned in our logs unit about the irrational number e. So that is kind of an overview of the whole family tree. But we're going to start to move into complex and imaginary. So again, a complex number in standard form, this is where we have a real part plus an imaginary. So when we combine the real and imaginary together, we get a complex number. And proper standard form is real first, then imaginary. Now, these complex numbers can be seen on the plane. Upgrading from the imaginary number line, now we're looking at a coordinate plane that has imaginary solutions. The first number that's already plotted for us right here is this arrow, which represents 2 plus I. If you remember when we plotted imaginary numbers on the number line, I would be like 1 times I, and that's why this line is pointing up 1. It goes up to I. But if you notice now we have this 2 out front. And so that actually directed us to move to the right 2 spaces to where 2 is on the real number line. So we go over to the real and then we go up or down to the imaginary. So let's try to figure out what point A represents. So we're going to start by finding the real. So we go over to the real, starting at 0, we go over to -4, and then we go up to A, up 3 spaces. So put that together, that would be -4 plus 3I. All right, so that is the complex number for point A. Let's see if we can graph some of these other complex numbers. So point B, we're going to graph, it's at -2, -I. So I'm going to start by going to the real number, -2. And then I'm going to do the imaginary -I. Here is B. All right, let's try C. C is -6 plus 3I. So I'm going to go over to the real -6 plus 3I would be up 3I on the imaginary axis. And this would be -6 plus 3I, which is point C. All right, for point D, that's 5 plus 4I. So we're going to go to 5 on the real number line. And then we're going to go up to 4I on the imaginary axis. Here is point D. And last, we'll do E, which is 1 minus 3I. So we're going to start going over to 1 on the real. And then down 3 on the imaginary. And that's how we find point E. So this is graphing complex numbers, but we might need to first simplify those complex numbers. So here we have a few examples of complex numbers that need to be simplified. Anytime that you see a negative under a radical, we always want to simplify that and get rid of the negative and hopefully the radical if we can. So starting with number 1, I have 2 plus the square root of -9. Step 1, I'm going to simplify the square root of -9. Well, we know that we can break this up into more manageable pieces. The square root of -9, I can break up to be the square root of -1 times the square root of 9. And this helps me because I know that the square root of -1 is I, and I know that the square root of 9 is 3. So I can rewrite this as 2 plus, now, besides just proper notation being real plus imaginary, we also write I after the numbers, just like we do with X. We treat it like X a lot when we're writing these. So it's more proper to write 3I rather than I3. So the complex number we get for number 1 is 2 plus 3I. Now, the instructions go on to say, circle the real part and square the imaginary. So in this complex number here, the real part is 2 and the imaginary is 3I. Let's try number 2. In number 2, I have 5 minus the square root of -75. All right, so I'm going to start with the radical again. We have the square root of -75, which I can break down to be the square root of -1 times the square root of 75, which is good because we know the square root of -1 is I, but 75 is not a perfect square. So this is one that you might need to start simplifying by hand, or if your calculator will help you with this, that's great too. For the square root of 75, I'm going to break this down one more time into the square root of 3 times the square root of 25. And now I can simplify these pieces because I know that the square root of 25 is 5. bring down the square root of 3, and bring down I. Now, to properly write this, it would be the 5 first, then I, then the square root. Remember, this just represents the square root of negative 75. Now we need to put that back into the complex number. So this would become 5 minus 5i times the square root of 3. In this number here, 5 represents the real, and 5i radical 3 altogether is the imaginary piece. All right, number 3, step 1 is to simplify that radical. Square root of negative 16 would be the square root of negative 1 times the square root of 16. The square root of negative 1 is I. The square root of 16 is 4. So we get 4i. So now I have 4i minus 6. Now this is not a finished answer because we need to rewrite it in standard form. Real goes first, imaginary goes second. Now before I rewrite it though, it might be helpful to go ahead and circle and square the real and imaginary parts. So we have the imaginary part is 4i. The real part is negative 6. So when I rewrite this in standard form, I need to make sure that the sign stays with its piece. So I'm going to move the real part first, negative 6. And I'm going to move the imaginary part second. That's a positive 4, so we get plus 4i. And there is our answer for 3. Finally, number 4, I've got the square root of negative 12. I'm going to break this down into manageable pieces. So we've got the square root of negative 1 times the square root of 12. I know the square root of negative 1 is I. Now, 12 is not a perfect square. So again, this is one we're going to try to break down even more. I could rewrite that as the square root of 3 times the square root of 4 because I know that the square root of 4 is 2. And I'll bring down the square root of 3. Putting all of those pieces together, we get 2i square root 3. Now, circling the real part, there is no real part here. This is simply imaginary. So we'll box this imaginary piece. All right, you try and see if you can do this last one. Pause the video and then come back to check your answer. For this you try problem, we have 2 radicals, so I need to simplify them both. First, I have the square root of 16. Don't let this fool you. This is the square root of 16, not negative 16. So this is just 4. Bring down that negative, so we get negative 4 plus, now we simplify the square root of negative 49. The square root of negative gets me I. And then the square root of 49 is 7. So the answer there is negative 4 plus 7i.